Hi there everyone. In this video today we're going to be looking at the antiderivatives of trig functions for sine and cos. So we've done the derivatives, we know what the derivatives are, so this video is going to be some examples going through antiderivatives. So you can see the result in the box hopefully is pretty obvious once we understand the relationship between the derivative and an antiderivative. If the derivative of sine is cos, then the antiderivative of cos is sine. So going backwards, if the derivative of cos is negative sine, then the integral or the antiderivative of sine will be negative cos. Okay, so some basic ones there. So let me do some examples around those and we'll get into the ones down here where we're using the reverse chain rule. Okay, so the antiderivative of 8 sine 2x, this is the way I think about A. And of course we've got dx on the end, so this is what really they're asking us, the integral or the antiderivative. When I'm thinking of these antiderivatives, I just put the numbers out the front, so this is really what I'm thinking in my mind. Let's just put the 8 out the front there, leave that, and let's just do the integral or the antiderivative of sine 2x on its own. So let's think about this. If the derivative of sine is cos, then the integral of sine is going to be negative cos. So I reckon the answer is going to be negative cos 2x. Okay, so just forget about the 8 for now, okay? Just forget about that for now. What would happen if we then now differentiate that answer? We're not going to get the right answer, are we? Because we know when we differentiate this thing here, the answer is going to be sine 2x times by 2, right? Therefore, we have to think of the reverse chain rule here, just like we did for polynomial functions. So in order for this answer to be right, what I'm going to have to do is add in a half there at the front. So now this answer is going to be correct. So let's check it out. We've got 8 times negative a half there, so negative 4 cos 2x, that's my final answer. Now you can always check by differentiating. The derivative of negative 4 cos 2x will be negative 4, the derivative of cos 2x will be negative sine 2x times by 2. Correct. So that gives us, two negatives cancel each other out. 4 times 2 is going to be 8, so we get 8 sine 2x, which is exactly what the question is. So we know that we've got that one right. Okay, so that's my little step at the end to make sure that I've done the right thing. So we're talking about the reverse chain rule here, but for trig functions. Part B, we've got the integral of 8 cos 2x plus 1. Okay, let's see if we can do this one. So, again, I'm just going to kind of put the 8 out the front there. The integral of cos is sine. So I know this is going to be sine of 2x plus 1 plus c. Yeah. So that looks good, but we've got this 2x plus 1 to worry about. I have to take into consideration the derivative of that function. So when I differentiate this, I'm going to be timesing by 2. So to undo that effect of timesing by 2 when we do the derivative, I'm going to put a half at the front. This is the reverse chain rule coming in here, guys. Again, but applied to trigonometric functions. We've also done this with exponential functions. So 8 times a half there is going to be 4 sine 2x plus 1 plus c. And again, if you differentiate that, 4 sine 2x plus 1 will be 4 cos 2x plus 1 times 2, and we get the answer. So part C, cos 5x plus sine 2x, cos 5x plus sine of 2x dx. Alright, one at a time. So the integral of cos 5x will be 1/5 sine 5x. So now I'm doing the reverse chain rule just in my head as I go here, and the integral of sine 2x will be, I need the negative a half cos 2x plus c. Okay, and if you check those, that is going to work out, because the integral of sine is negative cos. It's cos of 2x, and this is where the reverse chain rule is coming in there. So let me write kind of a general rule here. If you're doing the integral of a trig function, let's say sine of ax plus b, so that ax plus b could be any linear function, the answer will be negative 1 over a cos ax plus b plus c. Okay, and there's the reverse chain rule right there. If you're doing the integral of cos ax plus b, probably got this one, you're going to have 1 over a sine ax plus b. So there's some like general rules there that for doing the integral of these basic trig functions.